Right now, 64 light-years away, there is a planet where the wind blows at 7,000 kilometers per hour. Fast enough to circle the entire Earth in under 3 hours, and it isn't carrying dust, it isn't carrying sand. It's carrying glass, molten glass torn loose from the atmosphere itself, hurled sideways through the dark. At 7 times the speed of sound, the planet is called HD 189733b. It's real. It's out there right now. By the end of this video, you'll understand how we found a planet bleeding glass into space, why its sky is the wrong color for the wrong reason, and what's actually happening on a world where the weather itself could shred a spacecraft. And there's one detail about this planet, something almost nobody mentions, that makes the glass rain look like the easy part. First, the basics. HD 189733b sits in the constellation Vulpecula, orbiting a star slightly smaller and cooler than our Sun. It's what astronomers call a hot Jupiter, a gas giant, roughly the size of Jupiter, but dragged in absurdly close to its star. So close that one full orbit takes just over 2 days. That proximity is the root of everything that follows. A planet locked that close to its star gets cooked. Surface temperatures on HD 189733b reach around 1,000 degrees Celsius, hot enough to melt silver, hot enough to vaporize lead. And because the planet is tidally locked, the temperature difference drives some of the most violent winds ever measured. Here's where it gets strange. In 2013, astronomers using the Hubble Space Telescope measured the color of HD 189733b directly by tracking how its light changed as it passed behind its star. The result was a deep, vivid blue. For a moment, it sounded almost familiar. Earth is blue because of our oceans, reflecting sunlight back into space. People assume this distant world might be blue for a similar, gentler reason. It is not. The blue on HD 189733b comes from silicate particles, essentially the raw ingredients of glass, suspended high in the atmosphere. These particles scatter blue light the same way our atmosphere does. And the wind doesn't just stir that glass around, it launches it. Atmospheric models suggest wind speeds reaching up to 7,000 kilometers per hour, blowing horizontally from the day side toward the night side. Now, before you picture something cinematic, glass shards slicing through a stormy sky, we need to slow down on what rain actually means here. This isn't rain the way you understand it. There's no surface to land on. The silicate particles condense in the upper atmosphere, then get torn apart and redistributed by wind shear. It's less a rainstorm and more an atmosphere tearing itself apart in real time. And the violence of that wind raises an obvious question. What would happen if you were actually there? The honest answer is that you would never find out, because you'd never reach the clouds. HD 189733b has no solid surface. Like Jupiter, it's a gas giant all the way down. Descend far enough, and the crushing pressure alone would kill you long before the glass-laced winds did. But if, hypothetically, you could hover in that atmosphere in some impossible spacecraft, the wind alone would be enough to flay the hull. 7,000 kilometers per hour is 6 times faster than a hurricane. Here's the detail almost nobody talks about. The planet isn't just hot and windy, it's also leaking. HD 189733b sits close enough to its star that intense stellar radiation is stripping away its atmosphere. Observations detected the planet's atmosphere escaping at 1,000 tons per second, forming a faint, comet-like tail trailing behind. This world is not a stable object. It's actively dissolving. So picture the full scene now. A gas giant locked so close to its star that a year lasts barely 48 hours, glowing nearly white-hot. Winds powerful enough to outrun a rifle bullet tearing glass sideways. An atmosphere that scatters light into a deep blue from suspended rock fragments, and the entire planet slowly bleeding into space, leaving a faint trail behind it like a wound that never closes. Early exoplanet science was full of monsters like this. Simply because they were the only ones we could see, it took better telescopes to find smaller, calmer, rockier worlds hiding in the data. It isn't just an oddity. It's a survivor of detection bias, the loud planet at the front of the room, drowning out the quieter ones we almost missed. Every gentle world we've found since has been found despite them. And there's still uncertainty about how it ends. Researchers speculate whether worlds like this can shed enough mass to evolve into a chthonian planet, a gas giant reduced to its bare rocky or metallic core. Whether the star will allow enough time for that transformation before other processes intervene is genuinely unresolved. So here's where that leaves us. 64 light-years away, there's a planet with a sky the color of oceans for the wrong reason, winds that would outrun any storm, and an atmosphere disappearing into space. We like to imagine alien worlds as either lifeless rock or a mirror of Earth. HD 189733b is neither. It's something closer to a planet caught mid-collapse, beautiful and violent at the same time. Glowing blue for reasons that have nothing to do with water and everything to do with glass. The universe doesn't run out of ways to surprise us. It just waits for the instruments to catch up.